Swayam Prabha. Digital India. Educated India.
Welcome to today's lecture, and we have been discussing about the mineral exploration methods, going by the trying to have the very preliminary idea, basic idea about the principles involved in using them for mineral exploration of different types of deposits. And last class we just saw a very good example of how remote sensing technique can be useful for discovery of porphyry copper deposits, and similar situations are there in many other types of deposits, because of the fact that remote sensing technique also is a method which is first can be used to decipher the surface features. So, any mineralization which is resulting in very conspicuous identifiable surface features, say for example lineaments can be better identified or better analyzed by looking at the satellite imageries, and if there are some specialized analysis of the digital images for extraction of lineament and features like drainage pattern, sometimes the physiographic guide that we were discussing about in the context of geological exploration, paleo channels or large scale shear zones, again manifested as large scale lineament, and more importantly with better and better methodologies for processing of this digital image data, we would possibly in a position to discriminate the rock types to very minutest details. For example, depending on the spectral characteristics, even a mafic rock from an intermediate rock to a felsic rock also could be very well discriminated, and even many of the important information about the lithology of the area could be obtained by the image by the remote sensing technique, and they are very effectively utilized in producing more accurate dependable geological map than what was previously possible by conventional field exercise. They have been able to help a lot in this respect to field work, although the fact remains that they need to be first checked with ground observations of the field checking, which are essential. But once it is done, for example, if a particular area bearing hydrothermal alteration signatures, if it could be checked or could be cross checked only once by physically examining a particular spot from where the satellite imagery of that area has been acquired, then the similar features could always be extrapolated to other different areas which has been rather inaccessible or has not been possible to be mapped by conventional manual methods. So, remote sensing techniques in that way have come with a lot of advantages in supplementing to geological field work, and especially when it comes to utilization for mineral exploration. So, today let us have a look on a interesting exploration method which is utilized for exploration of diamondiferous kimberlite. We all know that we will be looking at we will be discussing, coming back to the discussion of the discovery of or exploration of diamond again, but we will see how our geological knowledge of geological understanding on the formation of the kimberlite will help us in formulating or in designing an exploration program for diamond. Here this feature we have seen before in different other type of diagram. This is a general the sketch giving the. So, this is the graphite diamond boundary. So, below which diamond is stable and above which diamond is not stable, and this shows the region from which the kimberlitic magma is generated and travels through the mantle and the crust to be ultimately getting extruded on the surface to form the dikes, the kimberlite or the lamproite type of dikes or the diatreme. This represents a thickened ancient craton, and this represents a mobile belt where the crust is thinner. Similarly here, and so what we basically observe here that the kimberlite magma which is generated in the asthenosphere in depths ranges where the diamond is stable is most likely to incorporate or engulf this diamond which are present already there in the diamond stability field and carry them up in the form of the kimberlite which will be containing the diamond. Now, as far as the diamond exploration is concerned, it is also important to remember that if we go by the abundance or the concentration, even if we say that a kimberlite is diamond bearing, but then the diamond is present in very small quantity of the order of like about 5 or 10 carats per ton, that is per 1000 kg of the rock, where a carat is about 200 milligram. So, we know that they are almost like as trace as the other precious metal like gold that we discussed before. So, it is basically very difficult to physically find a diamond crystal all the time in a kimberlite pipe. So, then it becomes more important to know, and since there are kimberlite bearing diamond bearing as well as diamond non bearing kimberlites, it becomes very important to discriminate, to have some criteria to distinguish them, that which of the kimberlite are most likely to carry diamond and which are not, so that whenever we encounter a kimberlite pipe in the field, we can decide either to go for a expensive exploration efforts like drilling of that particular diamond kimberlite pipe or not to do it. And as we know that even if a kimberlite pipe has diamond, only a very small proportion of it actually is the precious gem variety diamond, and rest of it is the non gem bearing diamond. Even not considering the gem or the non gem bearing, we just have to see how we could go about or formulate the exploration of this precious stone. This is just to recall about the diamond window. This is the shaded part here. The shaded part here is the diamond window, which is explains the why we need to have a thickened continental crust where the geothermal gradients will be shallow and the temperature is high, and this defines when the graphite diamond stability line intersects, this defines the diamond window. So, this condition of pressure and temperature is the diamond stability field, and if a particular kimberlite pipe has to be generated or kimberlitic magma either is being generated or actually passing through this particular diamond window, is likely to be diamondiferous. So, this explains why diamond is more likely to be below the thickened Archean continental crust, in which the geothermal gradient is rather shallow compared to the thinner crust. So, this gives the classic South African model of a kimberlite pipe with old terminology and the revised terminology. So, this we know that is basically divided into the different phases with depth. The top part is essentially was known as the crater phases, or now it is being known as the volcanic clastic kimberlite or the VK. This is the pyroclastic kimberlite. As we discussed during the when we were trying to understand the process by which the kimberlites form, and the kimberlitic magma moves through the crust at a tremendous velocity and creates an explosive situation by heating up the groundwater which were within the shallow region of the crust, and they are extruded in the form of tubes and the volcanic clastics which are deposited on this crater, and later on they sometimes make depressions which are also very prominent geomorphic feature, and such kind of, and as we know that they occur in more than one they will occur in large numbers as dike swarms. So, they will make some prominent geomorphic features which can be identifiable on the surface. So, this is the hypabyssal kimberlite, this is the volcaniclastic kimberlite, this is the seal, this is the diatreme facies, and this is the general morphology of a kimberlite, and which the most interesting part would be the top part, which is the crater facies or the volcaniclastic facies, where there could be pyroclastic materials, and sometimes there are resedimented volcaniclastic materials here. And so, now if we want to select the target for exploration of diamondiferous kimberlite. So, we do have the global, regional and the local tectonics at the back of our mind, where the world's preserved Archean cratons are there. The lithospheric structure and composition, that the lithosphere is in a given area thick enough to extend into the diamond stability field. This we could always find out the from our general geological idea about a particular craton, and the diamond formation, the preservation, that they have the process occurred such as a rifting that would destroy diamonds. So, this there should this diamond, this kimberlitic pipe where they are excluded, this area should have been not have been disturbed any further tectonic or any rifting activity later on. The known host rock petrogenesis and emplacement is what host rocks do we expect to find diamonds in this area from. The country rock and source rock geochronology, that means do we expect kimberlites to intrude through or be covered by sedimentary cover sequences in this area, because if there are later covered by sediments, then the features, the surface features that we are talking about will not be conspicuous, then there should be some other kind of techniques. And the local tectonic controls. So, these all these points together will help in our selection of the target. So, the overall geological setting, the presence of such host rock and the later sedimentary cover, and the geochronology, because it is believed that they are present in rocks of older, so which are known as the archons in the terminology of diamond exploration. So, we will come to discuss which will be a very interesting situation corresponding to diamond exploration. We know that the diamond itself in the form of either a gem or a non-gem type diamond crystals, either very well preserved or to have undergone some amount of resorption during the process of their upward migration through the crust. They are in any case going to be very scarce, and it is very difficult that one will be encountering a diamond crystal normally in a kimberlitic material, kimberlite. But these kimberlites minerals, which are other abundant minerals like the chrome spinel, the pyroxenes, the chromite, even or garnet, more importantly garnet, topaz. So, these minerals which are also which are abundant in the kimberlite are the ones which will be available, which will be abundant, and more importantly these are the minerals which will survive the normal process of erosion if the kimberlite pipe is in an area where it is exposed, is actively being subjected to the weathering and to the erosion process, and which is more likely when the area which is very well dissected by streams, by rivers. So, here we use a method which is largely known by a name as indicator mineral exploration, which is by using a very simple geological principle. So, by using, so instead of diamond, some other mineral which will be representing for diamond, and which will be called as we call them as indicator mineral, or indicating the presence of diamond in that particular host rock. So, the indicator minerals by their property has to be such that they have to retain their characteristics without getting chemically altered or destroyed in the secondary weathering cycle. So, the indicator minerals are so these kind of indicator mineral are applicable to not only to diamond, but other deposits as well, like in gold, in platinum group of metal deposits, but for in case of diamond it is very widely used. So, these minerals diopside, the spinel, chrome bearing spinel, the garnet, topaz, fluorite. So, these could be the indicator mineral. Of course, gold itself could be indicator mineral when it is a gold deposit. So, the indicator minerals are mineral species that when appearing as transported grains in clastic sediments indicate the presence of the bedrock of a specific type of mineralization. They have distinct physical and chemical properties that help them to be preserved, that as I just mentioned. The grain morphology, surface texture and chemistry are important parameters indicating the lithology and transport history, because the grain morphology would be very much an indication from the kind of rock from which they are derived. So, these indicator what we are calling them as indicator minerals, they are likely to be dispersed in the area where the kimberlite pipes which are exposed are undergoing active erosion, and mostly in the obvious places will be the streams in the form of the stream sediments. So, this is a generalized flow sheet showing the steps in the sample processing used to reduce sample weight, concentrate heavy minerals and recover the indicator minerals. So, this the stream sediments in any area that is being, first of all, by our reconnaissance survey and the way we have defined that how we are going to choose a target area for exploration of diamond, and if we happen to be recovering the stream sediments in bulk quantities, then these indicator minerals somehow have to be recovered or have to be concentrated by virtue of their physical properties, and then to be examined what exactly they are indicating. So, the bulk samples of about 10 to 40 kg are recovered generally. This is for the geochemical analysis and archive. So, there the size ranges generally within less than 2 millimeter or 1 millimeter, and then they are pre concentrated, then the final concentration by using heavy liquid and other kind of media, heavy fraction, ferromagnetic separation, and then the non ferromagnetic fraction, and by that time we are able to if there happen to be the heavy minerals like the chrome spinels or the chromite or sometimes other heavy minerals. So, by this process of their enrichment we are finally able to recover this indicator mineral, and these indicator mineral are subjected to the study where we need to identify them, examine them, and then more importantly we are going to analyze them chemically. So, these indicator minerals, one of them which we will be considering here. So, through this elaborate process after the separation we are going to study them to extract the information that exactly what we are looking for, to pinpoint whether a particular kimberlite pipe which from which these indicator minerals are derived. Of course, our main objective is to find out or to locate that kimberlite, but before that we can do this exercise to have some idea that whether the indicator mineral that is coming from that source is coming from a kimberlite which is likely to be diamond bearing or not. So, this is a thing that we are using is a subset of indicator mineral which are termed as the diamond indicators, or the potential presence of diamond in the kimberlite. These minerals, these are the minerals for these are the diamond indicators, because diamond is rare. So, the subcalcic chromium bearing pyrope, that is garnet, this is one very important one. This is commonly referred to as the G10 pyrope garnet. So, the garnet, so this actually is come from a garnet bearing Husbergite or Danite type of source rock from the lower mantle, and this is popularly known as this chrome bearing pyrope as the G10 pyrope, and this chrome bearing pyrope commonly referred to as the G9 pyrope is coming from a garnet bearing lazulite source rock. and high sodium pyro almandine garnet and high chromium magnesium chromite. So, there are two different types of garnets which are discriminated based on their composition to G9 and G10, which we will see what their characteristic is. Sometimes you can also get chromium corundum as specific kimberlite fields. Sometimes magnesium bearing ilmenite, we also get spinel and grains of eclogeti garnet, as well as these are also the diamond indicator minerals. And essentially now this is leading to something which is a very routinely adopted analytical method for mineral analysis for phase petrological work. This method has come out to be a very important method to, because we of course have to analyze these grains, these mineral grains by using some microanalytical techniques. So, here are some of the features which are important. So, here it actually gives a comparison of the relative abundance of kimberlite indicator minerals from the 6 deep kimberlite fields in one of these diamond field from Canada. So, the dark one is for garnet, and this is for clinopyroxene, this is spinel, and this is ilmenite. These are from the different provinces, and we see that in some of the provinces this garnet dominates, and this is one of the interesting features here in the chrome bearing pyro grains that comes from the kimberlite. With sometimes they are observed to have a very thick caliphatic rim on this garnet. Now, this caliphatic rim is not quite very well understood, but the possibility is that these garnet grains in these generalists invariably they exhibit the evidence of breakdown. These are essential evidence of breaking down to caliphate rims. These rims consist of spinel, amphibole, phlogopite and other minerals, and they are assumed to represent the garnet decomposition at a magmatic temperature during transport of the host kimberlite from a very high pressure to the surface. So, that means whenever we see this kind of chrome bearing pyro grains and we see these caliphatic rims, that give us the indication that they were actually coming from great depths and they represent decomposition of the garnet in a magmatic pressure temperature condition. And these are also taken as very characteristic feature that is observed in the during the examination after they recovered as indicator minerals. So, this is the conclusive, this is the diagram which is actually is the most important and gives us the conclusive idea. So, this is a plot, this shows the that there are lots of such garnet grains which are recovered from the stream sediments through the process that is described, and the garnet grains are analyzed. So, this analysis is now plotted on a Cr2O3 versus chromic oxide versus calcium oxide weight percent plot. We get the electron probe microanalyzer, the details of which I am not going. This is a very standard microanalytical technique, analysis of minerals, giving the measured oxides in weight percent and also sometimes elements occurring in trace amount in several tens of ppms. So, this so here on this diagram, the diamond versus graphite boundary is also plotted, and the diamond field is here and the G10 G9 boundary on the compositional characteristic of their relative presence of chromium oxide versus calcium oxide. That means, the ones which are more calcic is the G9 garnets, and the ones which are falling here as the G10 garnet, and when this G10 garnet falling in the diamond stability field are the kimberlites which are likely to be diamond bearing. So, here this solid square represent garnet plus chromite plus graphite, and the solid diamond represent the garnet plus chromite plus diamond. So, this gives us a very conclusive idea So, these are the entire areas in which it will be graphite will be stable here along with garnet and chromite, and this field will be the field for diamond stability. So, Cr2O3 CO composition on garnets and graphite bearing or diamond bearing peridotites generally with coexisting with chromite or lacking coexistence of chromite, here it is shown. So, this is the this dashed line is the graphite diamond constraint, this dashed line, as I already described, diamond is stable on the above this, this represents the compositional field in which the garnet is coming from, is a diamond stability field. So, this is a very interesting case in which a geological method is being utilized for exploration of a precious gem like diamond. We will again be coming back to look at the case history of discovery of diamondiferous kimberlite using other methods, for example, any kind of any geophysical method or geochemical or other geological methods. This is just a schematic, this is a sketch just to show as what exactly happens in a stream sediment survey. So, if we think that this is the hidden kimberlite body here, this hidden kimberlite body. So, this is an area which is basically dissected by a pattern of drainage in this, and as we all know that these are these smallest one are the first order streams. The first order streams join to give rise to the second order streams, and then the second order stream join to give the higher order streams. So, any stream sediment survey will be depending on, will be taking the stream sediments. So, for example, the highest order stream over here, if the diamondiferous kimberlite is being actively eroded from this particular point, then the streams which are coming and joining and forming the highest order stream here, the sediment will be containing the kimberlite indicator mineral, but then the position of the kimberlite has to be traced out by a very systematic thorough survey of the stream sediments, and to finally to be able to be locate at a particular the position where it is located. And so, this gives us a the summary of the thing, the use of the indicator mineral in diamond exploration. So, here the sample surface materials, soil, stream, sediment, or sometimes it could be the till also, which are which come from the glacial areas, glaciated areas. So, normally they could come, suppose if we talk about exploration in a situation where the kimberlite pipes have to be detected in areas like Bastar Craton or in Dharwar Craton, where we saw them. So, this kind of stream sediment survey could be carried out. So, sample surface materials, soil, stream sediments, recovery of the heavy minerals by the method that we described before, visually sort medium to fine sand fraction, and then identify and extract the possible kimberlite indicator minerals. These kimberlite indicator minerals such as the chromium pyro, chromite or chrome diopside, forsterite sometimes, and even picroilmenite. Do their composition and analysis, the major mineral element, electron microprobe, trace elements, and describe the grain characteristics, the size, surface texture, surface coating. It is just not only the composition that which always will be the deciding factor, even sometimes the grain characteristics also have to be well documented for that, and then this gives a confirmed derivation from the kimberlite or lamproitic source. They provide the initial indication for diamond potential of the area, and also provide indication of suitability of underlying mantle for formation and preservation of diamond. And here this while the composition gives us the idea about that this garnet is coming from a kimberlite which is most likely to have been diamond bearing have come from a mantle source where the diamond was stable, but that will essentially not give us an idea about how far the source could be from where it was recovered. So, these characteristics like the grain characteristics, size, surface texture and texture etc., will give us the information on the proximity to the source. So, this combined kimberlite indicator mineral results with sedimentological and terrain analysis to locate and prioritize the regions of specific target. So, in this we also put our hierarchy into order. So, if these are going on for the target detection, then finally when we are zeroing in and able to find out that where exactly the source kimberlite is, then it will be easier for us to locate it, like the previous diagram which I showed with respect to a hypothetical area which is dissected by a network of rivers or streams, from which we can draw the stream sediments. So, it is basically the indicator minerals and diamonds in the early stage of evaluation. This representative sample of the rock, kimberlitic indicator minerals, their separation, mineral analysis, they confirm the source, and here the it's actually this part, even if we get the diamond, so we can do the diamond analysis, for which, so depending on if we are only looking for the diamond kimberlite indicator minerals, then the amount of sample that we will be choosing will be less, will be of the order of 5 to 10 kg. But if we want to really even recover in terms of the diamond crystal, then we have to get even more than 50 or 50 kg or about 100 kg of the rock, crush them and then carefully separate out and get the diamond, then visual extraction of diamonds from residue and the weigh and describe the diamond individually. This part is only when we are interested in a. So, after we get the indication of a diamond bearing kimberlite, then the next step is that we have to assess that what quality of diamond this particular kimberlite and or this basically the commercial evaluation part, the total diamond weight fraction concentration, then the stone size distribution and this modeled concentration, and now this combine these all together and then decide whether to undertake the next stage of work, that is the bulk sampling, and whether to go for even further assessment of the quality quantity parameters and do the, I mean whether that particular kimberlite pipe has to be worked as a mine for diamond or not. So, that is a brief discussion or brief story about how diamond exploration can be carried out by using this simple exercise, but very important, which finally tells us about the very important result in terms of exploring for a diamondiferous kimberlite. So, we will continue discussing with other case histories. Thank you very much.